Today's lesson is on section 1.4. This video will describe the portion of the lessons that is functions and their graph. There is a different video that describes the difference quotient. Pause the video and work on warm-ups 1 and 2. After you finish warm-ups 1 and 2, unpause and check your answer. Here is the answers to warm-up number 1. Here are the answers to warm-up number 2. Warm-up number 2 is on function notation. Warm-up 3 and 4 you will come back to later after you've learned part of the lesson. So this lesson is on evaluating functions. We use function notation, which f of x, which reads f of x to represent y. Y and f of x are the same thing. There is always an input, which is x, an output, which is f of x, and a rule, and the rules all change. In this case, the rule for this function is f of x equals 1 minus x squared. The portion on this side is always the rule. Example 1. We're going to let f of x be 2 minus 3x plus x squared. This tells us the rule for f of x is 2 minus 3x plus x squared. When we're applying function notation, we treat the x as a parentheses or a something, and whatever is inside here goes in for x. So the rule for f says we do f of something, which says 2 minus 3 times something plus something squared. Now, whatever is inside the parentheses, in this case is negative 2, we replace the parentheses with negative 2. So we have 2 minus 3 times negative 2 plus negative 2 squared. Now we need to simplify. So we have 2 plus 6, because negative 3 times negative 2 is 6, plus the quantity negative 2 squared, which is 4. When we simplify 2 plus 6 plus 4, we get 12. So f of negative 2 is 12. 1b. 1b says we're going to find g of x plus 1. Now the rule for g is different. G says you take x plus 4, divide by 2 times x minus 1. So we're going to do g of something. And remember, the rule for g says you take something, which is our x, plus 4, divided by 2 times something minus 1. Those parentheses are determined by where x is in the function. Now in this particular problem, we're doing x plus 1. So every place there's a parentheses, we're going to replace that with x plus 1. So x plus 1, x plus 1. Now to simplify, the numerator becomes x plus 1 plus 4 divided by, now we need to distribute the denominator, so 2x plus 2 minus 1. So g of x plus 1 equals x plus 5 over 2x plus 1. Now return to warm-ups 3 and 4 and solve using the ideas that you just learned. Pause the video and then you can check your answers after you pause the video. Check your answers to warm-up number 3 and I will go through warm-up number 4 with you, which is a table. In this table, the first row represents all of our x values and the second row represents all of our g of x values or our y values. So this first question is asking for find the y value when g of negative 2. So we go to negative 2 on the x value, and then we record the corresponding y value. So g of negative 2 is 5, because that's the g of x value when x is negative 2. Now we're doing g of 10. So here's where x is 10, so the corresponding g of x value is 7. So g of 10 is 7. Now, we have 15. So our x value is 15, and our g of x value is negative 2. So g of 15 is negative 2. And then last, but certainly not least, is 30. g of 30, our x value is 30, so our g of x value is 10. So g of 30 is 10. Now return to example 2, and I will demonstrate how to do example 2. Now we have two new functions. We have the g function. G of x says x plus 4 divided by 2x minus 1. And we're looking for g of 3. So the rule for g is you take something, you add 4, and you divide by 2 times something minus 1. That is based by looking at the rule for g and replacing all the x's with parentheses. Now, inside the parentheses, we're trying to find g of 3. So every time we see a parentheses, we're going to put in 3. So then we have 3 plus 4, which is 7, over 2 times 3, which is 6, minus 1. So we have 7 over 5. So g of 3 is 7/5. Now the rule for f, here's the rule for f. The rule for f of x says you take 2 minus 3x plus x squared. So let's deal with the rule for x. So we have 2 minus 3 times something, because that's our x, plus something squared. Now the problem asks us to find f of x squared. So we're going to put x squared in for our parentheses. And every time we see a parentheses, we're going to replace it with x squared. And we're just going to simplify. So we have 2 minus 3x squared plus x to the 4th, because x squared squared is x to the 4th. So f of x squared equals 2 minus 3x squared plus x to the 4th. For the last part of example 2, part C, we're going to do f of x plus 3 minus f of x. Now, f of x plus 3, we're going to do f of x plus 3, so that's our something. And remember, the rule for f says we take 2 minus 3 times something, and we add that something squared. Since we're doing x plus 3, we're going to replace all of our parentheses with x plus 3. Now we're going to simplify this. We're going to need to do some distributing and some foiling. So we have 2 minus 3x minus 9 plus, now we have to FOIL x plus 3 times x plus 3. So we have a 2 and a negative 9, so we'll combine that. So we have negative 6 minus 3x plus, now we're going to FOIL this. So it's x squared plus 3x plus 3x plus 9. Now we're going to combine all of our like terms. So we end up with x squared, and then we have a 3x, a 3x, and a minus 3x, so plus 3x, and we have a negative 6 and a 9, so then those combine. Oh wait, it shouldn't be negative 6. It should actually be negative 7. So we have negative 6 and 9, and they combine to be plus 2. So f of x plus 3 is x squared plus 3x plus 2. Now we have to do f of x. So f of x is just 2 minus 3x plus x squared. Now the problem asks us for us to subtract the two equations. So we're going to subtract the green one, which is x squared plus 3x plus 2 minus the quantity 2 minus 3x plus x squared. When we distribute the negative, we get x squared plus 3x plus 2 minus 2 plus 3x minus x squared. Now our x squareds cancel, and our 2's cancel, so in the end, we just get 6x as our final answer. Pause the video and complete practice 2A and 2B, and once you have finished them, check them. Here is the answer to practice 2A. Here's the answer to practice 2B. We will now do example 3. Example 3 is a function that has specific domain restrictions. So the domain restrictions are given by this column right here. So when x is less than 1, you're going to use this function, which is x squared minus 5. When x equals 1, the function is just negative 3. When x is greater than 1 but less than or equal to 3, the function you're going to use is 2x plus 1. And when x is greater than 3, the function is 5 minus 4x. So let's look at we're finding f of negative 5. So negative 5 is less than 1, so we're going to use this function, x squared minus 5. So the rule says you take something, you square it, and you subtract 5. That something in this case is negative 5. So then negative 5 squared is 25 minus 5, which is 20. So f of negative 5 is 20. Now we're going to do f of 1. Now 1 means we're going to follow this domain. So that means our answer is negative 3. So f of 1 is negative 3. Now we're going to do f of 2. Now 2 is less than or equal to 3 and greater than 1. So this is the domain, so we're going to use the function 2x plus 1. So we take 2 times something and we add 1. That something is whatever is inside that parentheses, in this case 2. So 2 times 2 is 4 plus 1. We have 4 plus 1, which is 5. So f of 2 is 5. Now they also want to do f of 3, which is the exact same problem, not the same function, because it's x is less than or equal to 3. So the same rule, we're going to do 2x plus 1, but instead of plugging in 2, we're going to plug in 3. So 2 times something plus 1, that something is 3. So we have 6 plus 1, which is 7. So f of 3 is 7. Now the last one is f of 4. And since our last domain restriction is x is greater than 3, 4 falls in that category. So that function means 5 minus 4x. So 5 minus 4 times the parenthesis. That parenthesis is whatever's inside there, in this case 4. So it's 5 minus 16, which is negative 11. So f of 4 is negative 11. Now do practice 3, pause the video, and then check your answer. Here's the answer to practice 3. Our last example for this first video is on realistic domain and range. We all know domain is all possible x values, which is our input values. Range is all possible f of x values, or y values. In this particular problem, we're only looking at what is realistic. So the graph below represents the path of a baseball at a point 3 feet above the ground at a velocity of 100 feet per second and an angle of 45 degrees. The path of the baseball is given by this function. F of x is the height of the baseball in feet, and x is the horizontal distance from home plate. Now we care about the path of the ball. So all we really care about is where the ball started and when the ball hits the ground. Because after that, it's not realistic for talking about a baseball. So our realistic domain is all x values for the path of our baseball. So it goes from 0 to 315.5, because that is all possible x values that represent our actual ball. Now the range is from 0, because that's when the ball hits the ground, to the highest the ball gets, which is 81.13. So our realistic range is 0 to 81 13/100ths. This is the first part of the video. There will be a second video that describes and explains difference quotient.